Okay, last and by no means least is factor checking. So all these methods of factoring that you've learned about previously, um, it's all for naught if you missed a negative somewhere or if you applied the wrong method. So how can you check and see whether the factoring that you did was without error or was with the correct factoring method? You can do a polynomial multiplication table to find out. Now, a common method for doing factor checking is the FOIL method. And I think this is the traditional method that's taught in a lot of junior highs and high schools. Okay. Um, but if you don't remember that, or you want to learn something new, here's another way that I prefer, because to me it's a little more visual, and it makes it, I think, a little bit easier to check your work. Okay. Okay. So this multiplication table method is good at organizing the product terms very well. It typically aligns like terms along the diagonals. It provides a visual check to make sure no product terms are left out, and it makes calculation errors highly visible. So you can check and see if you made a mistake. Okay, so let's say you were tasked with factoring this polynomial, and as an answer, you came up with this product of these two expressions, x minus 5 times x plus 1. So what you do is you create this multiplication table where you have x times negative 5. I'm sorry, not times. X minus 5, sorry. And then you've got x plus 1. All right, so across the top, you have the first expression, and down the side, you have the other expression. And what you do is you just multiply column in a row, right? So x times x is x squared. X times negative 5 is negative 5x. Positive 1 times x is positive x, and positive 1 times negative 5 is negative 5. And what's nice about this is that notice that across the diagonal here, you've got your like terms. So the multiplication of those two expressions is going to be x squared, and negative 5x plus x is negative 4x, and then minus 5. So does x minus 5 times x plus 1 equals x squared minus 4x plus 5? Yes, it does, because we just did the multiplication using the multiplication table. And this works really well the larger this multiplication gets. So for example, if we had this expression times this expression, okay, this is what it would look like. Now, I typically will put more terms across the top and fewer terms down the side, okay? So this kind of stretches it out horizontally rather than vertically. Okay, so across the top, I've got 36x squared minus 30xy plus 25y squared. And then down the side, I've got 6x plus 5y. And now what you do is you just multiply column with row. So 36x squared times 6x gives us 216x cubed. Okay, minus 30xy times 6x gives us negative 180x squared y. And 6x times 25y squared gives us 150xy squared. Then down to the second row, 36y squared times 5y gives us a positive 180x squared y. Negative 30xy times positive 5y gives us a negative 150xy squared. And 5y times 25y squared gives us 125y cubed. Now look at this. Across the diagonals, we have our like terms. So we have 180 x squared y and a negative 180 x squared y. Those are going to cancel out. And then look across these other two diagonals. We have a negative 150y squared. That is a like term with this positive 150 xy squared. Positive 150 and a negative 150 with these like terms, those are going to cancel out too. So these will cancel, and that leaves us with 216 x cubed plus 125 y cubed. So does the product of these two expressions equal this sum of cubes? Yes, it does. So, if you're using the FOIL method, you have to kind of multiply, kind of like using distributive property, like that, and then keep all of those straight and then kind of reorganize them and add them together. What I like about this multiplication table method is it organizes the terms for you. It's not always going to be on the diagonal. Okay, just be on the watch for that. But it's very common that like terms will be on the diagonal. Okay, and they won't always cancel out. In this case, they did not up above, right? But at least you knew where to look for the like terms along the diagonal. Okay, that's it. That's factor checking with a polynomial multiplication table. Let me know if you have any questions.